Okay. Good catch. Because I stopped it because I wanted a different one and I did not remember to hit record. All right. Next one. Suppose you like to keep a jar change in your desk. Currently, the jar contains 18 pennies, 19 dimes. What is the probability that you reach into the jar and randomly grab a dime, and then without replacement, a penny? So remember, probability is what you have over which, or what you want over what you have, right? So dime is what? 19 out of 73. So that's the first one. What's the probability? Now, without replacement means what? I'm not putting that back. So what changes? The bottom one's going to change to 72. Does the top one change in this respect? Well, yes, because we're looking at pennies, but the dime doesn't impact that. So how many pennies are there? 18. Okay. So this is one of those problems that part could change. It could say, what's the probability that you're randomly going to grab a dime and then another dime? And then at that point, that top number would also have to go down by 1. Okay, so just keep that in mind. You multiply these two, 0.065. Wants 4 places. 0.0651. Those are both from chapter 6, yes. You good with this one? So real estate agent has 17 properties that she shows. She feels that there's a 30% chance of selling any one property during the week. The chance of selling any property is independent of selling another property. Compute the probability of selling more than 5 properties in 1 week. So what are they asking you to do here? We talked about something that has an either or situation. So it's true or false, yes or no.
Oh,
It was a binomial distribution. Remember, binomial distributions are the yes or no's. Bi means 2 options. Okay? So this one is a binomial distribution. This is the one that I said use this calculator. Okay? So what was the probability of success? 30%. So 0.3. And she sold 17, or she was looking at 17. and she wants to sell at least 5. Yes, this is 7-4. And she wants this. The question was worded as, what's the probability of her selling more than 5 properties in a week? So more than 5 is X is greater than 5. So the answer is 0.40318. So, or 0.4032, because it's 5 decimal places. So you'll start to notice most of the math that you're doing in these problems, not overly complicated so far. That's not the hard part. Okay. I would. There is a formula for it. Hold on, I'll get you the formula. Yes. Yep. Yeah, I'll have a post actually up there when I do the review for the final, and I'll put the 2 links for the calculators right there so you can easily find it. That's the actual formula. But you'd have to do it for 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. You'd have to do it like right. Or you could do the other direction, do 0, 1, 2, 3, 4, and subtract those off. That is the other way to do it. Using the calculator online is a lot easier.
Can you go back to the calculator part where you put the
Yeah.
So it's 17.
that's how much.
That's what must be.
All right. We good with that one? All right. The next one's actually 2 parts, but they go together. So you'd have to figure this one out to do the next part anyway. So, all right. So this one is, suppose you're playing cards. The bet that you would draw 2 cards without replacement from a standard deck. If both cards are clubs, your friend will pay you $403. Otherwise, you have to pay your friend $24. You want to find out expected value. Expected value is 2 pieces of information you need. You need the amount of the bet and the probability that you're going to hit that bet. Okay. So the first thing we have to figure out is, what is the probability that you're going to hit 2 clubs? And yes.
So I know nothing about poker cards, anything like that. And every time I've had to do any of these problems, I always either have to click on the link that says like standard deck of cards or Google it. Is that something I should put in my cheat sheet?
Yes.
How many kings, how many clubs,
Yeah.
how many red cards?
Or
how many black
I will
cards?
tell you, if you can't figure that out on the actual test, if you come ask me, I will tell you that number. Okay, I'll tell you how many clubs there are with something like that, so you can figure out the rest of the stuff. So that is fine. Learn how to gamble. All right. So what are the odds that are both cards are clubs? So we're doing without replacement. So the first, we have 13 clubs out of 52 times 12 clubs out of 51. So they want your final answer to 2 decimal places. So when you're doing like your interim problems, I would go to 4 decimal places. Give me my computer back. It's going to click off in a second. All right. So for this one, you get 0.0588. So we're going to take that number right there and multiply by 403. Okay? Like switching a million times. So that's 2360 or 70. 2370. All right. If we don't get that, we have to pay him $24, right? So that means we're going to multiply by negative 24. What's the number I'm multiplying that by, though? No, because that's if we win. It's the converse of that, right? So it's 1 minus that. So we're multiply it by 0.9412. And we get negative 2259. And then we add those together. 1 minus, so this is 1 minus 0.0588.
Thank you.
You're welcome. Because you win at that, everything else you lose. So you just want to subtract it. All right, so our expected value is $1.11. That means it's a good bet for you and a bad bet for your friend. If you play enough. Poker's, there's a lot of other stuff that goes in poker. Poker actually has a lot of strategy involved in it because you're playing against another person, so you really are like thinking about what they're doing. Blackjack, on the other hand, you're literally just playing against the dealer. It doesn't matter what everybody else has. So it varies. All right. What happens if you do the exact same bet 845 times? Right. All you're going to do is take that $1.11 that you just got and multiply it by 845. How did I well? And if you played it 845 times, you'd expect to win $937.95. That, now, not that this question asks it, is that experimental or theoretical? That's theoretical. You didn't do it. Okay? Experimental is when you actually physically did it. That's the difference between the two. So this theoretical. So you'd expect to win that, but you're not guaranteed to win that. You could win more, you could win less. Right. Pull two clubs out 3 times in a row, you're at $1,200. I'd stop right there. Your friend would probably stop right there too. Yes.
The 2259, that's supposed to be negative, right?
Yeah.
And then when
Because it was a negative $24.
okay, and so you add them.
Yep. All right. Moving on.
That was 9379 by the bottom, right?
Yeah.
Chapter 8-1.
Yes. All right. So the weights of certain machines components are normally distributed with a mean of 5.19 ounces and a standard deviation of 0.05 ounces. Find the two weights that separate the top 8% and the bottom 8%. These weights could serve as limits to identify which components need to be rejected. So if you think about it, we're looking at a nice little bell curve. And we want 8% down here and 8% up here. There's my seed table. So we need to find our Z's for those. Remember, it's symmetric, right? So if I find the negative side, I also find the positive side. This kind of sign. So we are looking at our negative side, and we're looking for 0.08. And I have negative 1.41.
That's close to 1.4.
Yeah. I will tell you when I'm grading the test, I'm grading this one. So if you're like that much off, I'm gonna give it to you. And even when I went back and graded, or went back and reviewed 6 through 8, the test you just did, if you were close, I gave it to you because I knew it was like a rounding error, and you just one off when you were looking at trying to count, so you were fine there. So, all right, so we've got our Z's. We now need the number that goes along with those Z's. So remember, my Z score was X minus the mean over the standard deviation. We're in essence looking for X. So I know I have negative 1.41 equals X minus 519 over 0.05. And then I have positive 1.41 X minus 5.19 over 0.05. So multiply by the bottom. and then add over the mean. And those are your 2 answers. All right. Any questions on this one? No. Okay. Well, you're finishing writing this? I'll do it. I didn't do it.
Yeah, I did something wrong.
That's the positive one. The other one is minus. You didn't put negatives in there. When you typed it in. That's because you got the exact same number, so you still added them. So I guarantee it's a minus sign. All right. Step 9. Suppose a batch of mesh shafts produced in a manufacturing company have a variance of 9 and a mean diameter of 207. What's the difference between variance and standard deviation? Square root. So what's the standard deviation? Right. Because it's the square root of 9. If 72 shafts are sampled at random from the batch, what's the probability that the mean diameter of your sample shafts would differ from the population mean by greater than 0.3 inches? So we're looking for,
Population.
right, so we've got our mean is 207, right? And we're going up to 207.3. So we want the percent that's over here, correct? Yes? Okay. So I need to know what the Z number for that one is, basically, to be able to figure out that percent.
So we would subtract them.
No, remember, I got to do my Z-score formula for it. But remember, this one's slightly different because I'm doing a sample, right, of mean. So it's going to be 207.3 minus the 207 divided by 3. Oh, was it 3 or 9? Hold on. I know. I'm just trying to remember if you got it. I put the square root in the wrong spot. 3 divided by the square root of 72.
This will be chapter 8.
This is chapter 9. So Z equals 0.849. Got this right. 8485. And 8485. Yeah. So that's my Z. So now I look at my table. Yes. So it's this 207.3 minus the 207 divided by 3 divided by the square root of 72. Because you have to divide by the number in your sample. Well, it's 3 is divided by the square root of 72 on the bottom. It's 0.3 divided by that whole piece. So when you type it, if you're using Desmos, it should look like that.
When you look it up on the chart, how do you know if it's negative or positive?
You know, your negative goes from 0 to 5, 0.5. So this is going to be a positive number because it's above half.
So it's 1 point.
Wait. Oh, yeah, it would be both sides in this case. You're right.
Yeah.
You're right. Oh. But the nice thing is what? Should be the exact same. So I'm looking for 0.84 or 85, 0.85 actually.
1.04.
Well,
8, hold on, is 0.80234. That's your Z,
Yeah.
not your percent. So you're looking at Z, not inside the table. So from there to there is 0.80234. So what's the number over here? Okay,
We're not.
that's your Z, right?
Yeah, we find the Z.
So find Z.
Yeah, I did.
So you're looking for 0.85 in Z. You're not looking in the middle of the table.
You're not looking.
No, that's not a percent. That is Z. So you're looking for 0.85, which is 0.80234. Hold on, I'll pull up the Z table so you can see it on the screen.
Oh, okay, so it's.
So how do we know if we're looking in the?
Oh,
table?
If you got a percent or a Z score. This is not a percent. This is a Z score. So we found Z.
Yeah, okay.
So I'm looking for 0.85, which is right there. That's 0.85. Right. So this number right here, when I subtract it, the piece here is 0.19766. I have to double it to find that side too. So your final answer is 39523.
So we found the Z score, which is
Mhm.
0.85. Found the percent, which is 0.80234.
Right, but remember the percent in the table is from the left all the way over, and I want just the upper part over there. One minus it. Correct.
And then you added that.
And then I doubled it to find the bottom part down there. Because it's symmetric, it's the same on both sides, because they're both 8%. If they weren't both 8%, I would have had to do different things on either one. Yes,
So I solved it,
or 0.3.
I just for the left side.
That's fine. If you did the other side, you should. No, it should have been negative 0.3.
Like, once I solved the Z, I plugged in negative 0.3 over.
Right. You should have gotten a negative exactly the same number. So my odds are you say something wrong. Oh. You did the square root of 207. Oh. Well, that was the exact same number you used to the next one.
Where did we get the 0.19766?
It's the
Right,
one
what I'm saying is
minus
the
the
0.208 is numbered.
80234, because when
Because you
we
used
find
207.
it, it's going from the left and
That's
up,
72.
but we want to the right, because we're looking for greater than 0.3%. So then you do the
Yeah, the
opposite.
process is
side.
totally right. You messed that one number up.
And then you're just adding it because you're also looking at the other side.
You're looking at both sides, so you have two pieces.
So you would add up the 0.1976, but then on the other one, you do 1 minus 0.1976.
No, you're adding, they're both the same. It's symmetric.
So where are we doing this minus?
1 minus the 0.80.
Right. Because remember, the number you're looking in here is always from left all the way over.
more than that, more.
Hold
than
on.
207.3 and
Yeah.
less than 206.7.
Give me 1 second. I'm going to read.
No, more than two. Yeah. it was, okay.
Confusing, it's
One
right.
says Right in the left.
Okay. So here's my thing, right? 207, correct? I'm looking from 206.7 to 207.3. And I'm looking at this spot and that spot, correct? That's what I'm looking for. What we figured out was we figured out from here to here was 0.80, what was the exact number? 23. We figured that out. Okay? But I needed this piece over here. So I do 1 minus it. And that's where I got the 0.19, whatever it was. Da, 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 da.
1976.
And then you add those.
And this side is also over here, is also 0.19766 because it's the exact same. Add them together to get the final number, yes. Because I want the total outside. All right. Next. Economist wants to estimate the mean per capita income of a major city in California. Suppose the mean income is 24.3 for a random sample of 758 people. Assume the population standard deviation is known to be 9.2. I'm going to guess, oh, this is in thousands of dollars. Okay. Construct the 90% confidence interval for the mean per capita income in thousands of dollars.
Chapter
10. This is 10. So I need to know my Z for a 90% confidence interval. Right. So that's your Z. So now we have my, or suppose that the mean income is 24.3. So it's 24.3 plus or minus 1.645. That's your Z. So this is my mean plus or minus the Z. And then it's times my standard deviation divided by my square root of the sample. So this is 9.2 divided by the square root of 758. So they want it to 1 decimal place, so 23.8 to 24.8. Good with that one? Okay. Here's an easy one for you. What's the null hypothesis and the alternate hypothesis?
Well, null hypothesis is 6.8. Not equal to 6.8 or less than.
So 2 pieces of information you need to tell me from my.
6.7.
Okay. You're missing a very, very important piece of this. That's important. We've looked at many different null hypotheses so far. Okay. So you have to make sure you write the right symbol here. That matters. So it's mean. And I know that's equal to. I'm not sure what the last one is yet. Okay.
So then it's gonna be less than.
So now, remember, we need to make sure we're using the population mean and not the sample mean. The sample mean is 6.8. The population is 6.7. And then it says, is there significant evidence that the valve does not perform to the specifications? So is it going to be less than, greater than, or not equal to? Not equal to. Okay.
Yeah, this says less or more.
Right. So there's got to remember, unlike, actually, I don't know, Hawks actually did, you had to write the whole thing too. Like you have to write the whole thing out. Of course, I closed it up.
Yeah, I saw the go.
Oh, no problem.
Thank you.
You're welcome. I will see you on Wednesday. So you have to make sure you're using the right things, not just,
And this is what when it says, like, it puts the sample at the
Yes.
beginning and it makes you think that that's. maybe-
Yep. That's going to matter. All right. Sure.
I wasn't, done writing.
I'm going to post them all up top too. I'm going to post it on my site too.
Was it chapter 11?
This was chapter 11. Next. Yep. I'm going to post these notes that I'm writing on the board right there, just like all the rest of them. No problem. And the videos. All right. An engineer designed a valve to regulate water pressure. The engineer designed the valve such that it would produce a mean pressure of 4.3 pounds per square inch, and it is believed the valve performs above the specification. The valve was tested at 280 engines, and the mean pressure was 4.4 pounds per square inch. Assume the variance is known to be 0.64. A level of significance is 0.05 will be used. Make the decision to reject or fail the null hypothesis. So this is purely hypothesis testing. So first thing we have to determine my null hypothesis, my alternate hypothesis. So what is my null hypothesis? Right. So mean is 4.3. Alternate hypothesis performs above, so it's going to be greater than 4.3. So this is a one-tailed test. We have a significance level of 0.05. Am I using P or Z or T or Z? Correct. We know Z because we know the variance for the population. Oh, wait.
So that's like
Hold on a
the
second.
variance for the.
No, actually, it says assume the variance is known. So that's population variance.
Oh, that's.
It did. It said if it said the valve was tested 280 is the mean pressure of that and a variance of, then that would be part of the sample. It says assume the variance, so this is Z. And they gave the variance. So remember, you have to do the square root of that. This is where your work's going to be important. Because like if you go through and do all this stuff out with 0.064, okay, assuming that's about your standard deviation and get like, but you show me all the work that you do understood that all, I'm not giving you no points. Okay, because obviously you knew all the steps, you just screwed up the variance and standard deviation. That's a couple points off. If you don't show me any work though, and you just give me an answer and you did that, you're gonna get all the points off because I have no clue where you screwed up and it wasn't the right answer. So showing your work, very important in this case. All right, so it's one-tailed, we're going to be greater than. So we're looking up here. One-tailed at 0.5 is 1.645. So that's there. Now I need to find the test statistic. I need to find my Z. So I have 4.4 minus 4.3 divided by 0.08 over the square root of 280. Oh, is it 0.8? Oh, you're right. It is 0.8. That's okay. 0.8. You're right. Add this in places.
Double check to make sure that it was actually 0.08. But it's.
I did it in my head. That's where I screwed up the decimal. You didn't actually mess me up. But if you want to blame yourself, I'll gladly take it. So 2.09. So we're up here. So we reject. So there is significant evidence that the valve performs above the specifications at a 0.5 significance level. Oh, yeah. You're welcome. I'm going to turn on this light. All right. Next. We're going on audit, so pretty much everything after this point is going to be hypothesis testing. Have a good night. All right, automobile manufacturer claims Breed has this. An independent testing firm has been contracted to test it. After testing 230 Jeeps, they found a mean of 33.1. Assume the standard deviation is known to be 2.5. Levis convicted to 0.02 will be used. So this is exactly the same as the last problem. We know our standard deviation. So what's my null hypothesis? The mean is 33.4. And my alternate hypothesis is not 33.4. Because it is incorrect. It doesn't say higher or lower, it just says it's incorrect. So I'm doing my significance level is 0.02. It's 2 tails. And it's Z. So 2 tails, 2 is 2.326, and negative 2.326. And the formula for Z is going to be the same as the last one we just did. So I have 33.1 minus 33.4 divided by 2.5, because they give you the standard deviation for this one. Square root of 230 is my n. I get negative 1.82. So it's in here. It fails to reject. So there's not significant enough information to reject the claim that it is incorrect, or to accept the claim that it is incorrect. Huh?
I said it was only a difference of point.
Yeah, but it could be really small depending on how big of a sample you have. 230 is a bunch of cars, so you're not going to get that huge of a sample. But it was, and a lot of it has to do again with the significance level. It'd have been a lot closer if we did a 0.5, 0.05. It'd have been 0.19 that, so it'd been a lot closer. But at a 0.02, it's not.
Fail to reject and reject are on one side of the other.
Fail to rejects normally in the middle, or if it's one tail, it's not on the exteriors. Because remember, you're basically looking for extreme cases. You're looking on the tails. So if it's not in the tails, it's failure to reject. If it's in the tails, it's the reject. So normally I color in my reject region. I just didn't do it on this problem. That's the reject region.
And reject would be on the tail.
Yes.
I started to learn this.
Yeah. If I remember, I will put a bell curve on these problems. on the test.
What happened?
I will put a bell curve in the actual test paper. So this way you can just use that. You don't need to use the stickers or anything else like that. It'll be there. If I remember. All right. Next. So design a valve such that it will produce a mean pressure of 7.5. They want to know if valve performs above. The valve was tested on 24 engines. The mean pressure was 7.8 pounds with a standard deviation of 0.7. A level of significance of 0.05 will be used. Okay. What's my null hypothesis and my alternate hypothesis?
No, is, I mean, is equal to 7.5. Alternate is 7.5.
So I'm doing a significance level of 0.05. One-tailed or two-tailed? One tail. T or Z? T. Because I have the sample standard deviation in this case. So I need my degrees of freedom. My degrees of freedom is going to be what? 23, because it's 24 minus 1, which is 23.
I feel like we're always using the TT.
Well, because it gives you the
Z.
Z at the bottom, so they all kind of fall in there, so it makes it nice. We did use that for a couple of the other problems, though, so. All right, so one-tailed, so we're looking over here. Because it's greater than the 7.5. So we're looking at 23, sorry, one-tailed 0.5 and 23. So 1.714. Remember, the formula is basically the same for those two. And I get 2.10. So it's over here. So I'm rejecting. It's in the rejection region, so I reject. So that means there is significant evidence that the valve performs above specifications. Four to go.
How many?
Four to go. That's fine. No, you're fine. All right. All right. So my null hypothesis. 433. Right. They want to know that they're underfilled, so it's going to be less than 433. All right, so we're looking at a significance level of 0.025. We have one-tailed or two-tailed? One-tailed. Are we using Z or T? T, because we have the sample standard deviation. So I need my degrees of freedom, which will be 25. It's 26 minus 1. So we're looking for a number down here. That's my rejection region. So one-tailed 0.025, 25 is 2.060. Oh, sorry, it's negative 2.0. So we got so negative 2.0 or 2.10. So it is in the rejection region. So we reject. It's less than. So we're on the left side of the graph. So yeah.
There is sufficient evidence. There is.
Yes, there's significant. Yes.
I don't know, or the last week is gonna also be.
No, there's one from chapter 12. All right, the next one's the same as these, so I'm gonna skip that one. I'm not gonna do another one of these. It's the same thing.
Wow, lots of golden numbers.
This is chapter 12. This one's gonna be it's just a bunch of pieces, but they all basically flow together. So instead of me just saying what's it's different parts to it. So all right. So start off the same way. What's my null hypothesis? What's my alternate hypothesis? You just go, well, there's a whole bunch of writing, so I'm going to go with it's probably going to be subtraction of means. So minus U2 equals 0. Now the question is is it not equal to, less than, or greater than? So we have to look at, let's see what it says. So science should be reviews and traditional interactive sim had a standard that the test score is lower for students taught in traditional lab. So, right. So U1 minus U2 is less than 0. Okay. So we're using our significance level of 0.05. Assume they actually nicely, they tell you assume the variances are equal. So we're going to use the equal one. And we don't have the population variance. So we need to use the formulas for when we don't know the population variance. But when it's equal. This section. Yes. Hold on. I'm trying to find the formula for it because I'm like, this was that long one. All right. So actually, step one is just that. That's all they were asking in this part of the problem.
It was just asking for the.
They were just asking for that. Okay. Next part of the question is asking for the test statistic. This is that wonderful formula here. Yes, it's this one. And remember, we don't even need to use that part. It's really just that the S part that's the annoying piece.
We do both of them, right? We did the T first and then the S.
Well, no, we actually have to do the S because you need the S in the T.
Oh, yeah.
So we need to do that bottom part first. So we have N1 is 16 minus 1 times standard deviation of 5.7 plus second one was 11 times, see you Wednesday, standard deviation of 6. Oh, don't forget the square. And then we had 16 plus 11 minus 2. So that's what they get for us. Yes, don't forget the squares. So my mean was, what was it? Hold on. I scrolled up when I shouldn't have. There we go. 77.5 minus 85.9. Square root. So there's your T. All right. Write all the formulas down. So I guess my question to you is, while you guys are writing this down, it's the same number of points no matter what. Do you want me to actually ask the four parts, or do you want me just to say, what's your decision? Like we did for the other ones.
I don't know. I'm sorry.
So I can actually write this as, these are just multiple parts of the same question. So I can write it out where it's asking you like the four pieces like this. Like give me the null hypothesis, alternate hypothesis, calculate the T statistic, calculate the rejection region, make your decision. I can write it that way out, or I can just say, what is your decision? You have to do the exact same amount of work no matter which way I ask it. You want to write out the steps? All right. Okay. So we've got our hypotheses, we've got our the test statistic. We now need to find our rejection region. So what's my degrees of freedom? I've got two samples. Nope. This is the one we know they're equal. So we add them and subtract 2. If we didn't know they were equal, you would be right. We take the lower one.
Now
We need our degrees of freedom.
yeah, so
For
instead of,
we know that they're there, so we're going to add the two samples together and then subtract 2. So it's 25.
you always subtract 2?
In this method, yeah. When you add the two things together, because it's always the sample minus 1.
When they're,
Yes.
when they're not.
You're going to take the smaller one. In this case, they're equal. It says they're equal. So my degrees of freedom is 16 plus 11 minus 2, which is 25. It is one tail at 0.05. So my T is going to be, my rejection rate is going to be less than negative 1.708.
It's like step 3.
Yeah.
Well.
So degrees of freedom, we know it's one tail, significance level 0.05. So T is negative since it's less than, right? We decided it was less than?
Yeah.
Yeah. Since it's less than, it's going to be the negative version of that.
Well,
And the last part, what's the conclusion? So if we look at our bell curve, a horrible bell curve, that's a little better. 708. And I think my number was what? Negative 3.68. So we're over here. And it was -3 point. So it's well within the rejection region. So rejects. So the interactive software does show a significant improvement in their test scores. That's your final exam. I mentioned at the beginning, you guys were crazy. I'm almost positive the survey is open on Blackboard, so go into Blackboard, fill it out. I'd appreciate it.
The step 3, what was that doing?
Finding the T score that I'm looking at for my rejection region.